Thanks very much. Hi, I'm Sarah Parsons from the University of Birmingham in the UK. I'm here representing a large project team, as you can see, some of whom are listed on here, some of whom have joined since we submitted the abstract, so they're not listed, two of whom are also in the audience. Nirit Bowmanger from Bar-Ilan University in Israel. And Sarah Garib-Penna, who works with me in Birmingham. So I'm here to talk about our FP7 funded project, which is through the European Commission, started February 2009, finishes February 2012. So we're, just over halfway through at the moment. It's the Cospatial Project, and the aim of the project is to use and develop technologies to promote learning and understanding of social competence in children on the autism spectrum and their typically developing peers. Our focus on this particular project is on collaboration and social conversation. So it's very much about getting kids on the autism spectrum to be communicating and collaborating with each other or with their typically developing peers, depending on how they're paired up. And we're working with two different types of technologies on this project. One is a virtual reality-based technology, a collaborative virtual environment, and I'll say more about these in a minute. And the other is a shared active surface. And that is, and you've probably seen these out and about already, it's a horizontal surface in which 2 to 4 users can simultaneously interact with a tabletop application. The technology can be programmed to recognise touch by each user, so it's a multi-touch device, similar to what you were talking about, Wendy, Karen. And the social rules, in terms of supporting collaboration between the users of that technology, can be hardwired within the logic of the system. And a facilitator, a teacher, whoever, can work with the children and support their interaction between pairs of children to ensure that the educational objectives of the game or the task, however you describe it, can be achieved. A collaborative virtual environment is a virtual reality environment in which several users can simultaneously share the same space. I'm sure you're familiar with that idea by now. Each user in the collaborative virtual environment is represented by an avatar character, and that can be whatever we want it to be. And users can navigate around the virtual environment and communicate directly with each other via headset microphones. So they can be in the same room, talking to each other through the virtual environment. They can be in different rooms, in different buildings, in different countries, ultimately, if you wanted them to be. So you can separate out the interaction of those children there. And again, the importance of the facilitator here, because a facilitator can sit alongside the users using that technology and can also be one of the characters based within the environment. So there's always a facilitator available to help. I kind of feel like I don't really need to go over this, but I will go over it because it is important to remember why we think technology might be useful for children on the autism spectrum. We know there's a lot of technology out there. There's some, good examples today of what technologies are being developed. And we just need to remind ourselves why we think that's useful. We know that poor social understanding and behaviour and interactions are defining diagnostic characteristics of autism. We know, at least from the UK, and I'm sure it's not unique to the UK, I'm sure this is true everywhere else, that social skills training for children on the autism spectrum has been identified by parents as the single biggest gap in educational support. And we also know from research and anecdotal reports that various technologies have been demonstrated as effective and motivating for children with autism. For example, through learning vocabulary, through learning about facial expressions, learning about a whole host of other things. And we know, as I've said, from young people themselves as well as from parents about the motivational benefits of technologies for many children and young people on the spectrum. Why is technology good for children and young people on the spectrum? Generally, there's some common advantages to whatever kind of technology we're using. And it's these kinds of things. We can control the input levels. You can control the number of people present, what people are hearing, what they're seeing on the screen, the non-verbal cues from people, which we know that children and young people on the spectrum find confusing and difficult often. You can include visual prompts and scaffolds to support the learning objectives of whatever task you're teaching. We hope, anyway, that interactions via the computers using that medium are somehow less threatening because they don't involve that direct face-to-face interaction. And so we think that possibly some of the interactions through the computer can be more motivating for children on the spectrum. In a way, we think of this as collaboration by stealth. So we're getting kids to work together on things, but they don't really know that they're doing it yet. And it also means you can practice skills safely without experiencing the real-world difficulties or problems experienced through role play. So it means the real-world outcomes aren't there yet, so things can be practiced quite safely in the meantime. And we can also record and replay what's going on in the technology. And of course, that's very helpful for then reflecting on what's been happening in the use of the technology and using that as part of the learning objectives too. In terms of the specific advantages of these technologies, there's a few, although mostly actually they share the common advantages. In terms of CVEs, we think that the potential to develop quite rich representations and realistic-looking representations means that there's a potential for greater facilitation of generalisation between the real and the virtual worlds. We hope that's the case. In CVEs, it also allows for perspective taking because you've got different users looking at the environment from different computers, looking at things from different perspectives. So in terms of autism, we know that's a particular problem, and we hope that that's something that we can develop, and I'll say more about that in a minute. In terms of the shared active surfaces, you can have encoded patterns of collaboration within the technology. So they're embedded in the structure of the application. And that means that people can take on different roles within the use of the technology. You can do that through constraining the movement of the objects, and also children can have ownership over particular aspects or interaction within that particular technology. And of course, it's very appealing. It's a tangible user interface that is easy to use, and you get that immediate feedback from the touch.